Good morning, students. Today is Tuesday and it is May the 12th. Today you will be doing two things. The first is looking at simplifying expressions that have subtraction of like terms as well as addition of like terms. This adds on to the work that you did yesterday on the puzzle where you were just adding like terms. The second thing for today is a problem of the week. This problem of the week is something that you're going to type up your answer in Google Docs and you're going to submit it. It is due by the end of the day tomorrow. Okay, so you have today's math time and tomorrow's math time to complete it. I'm going to give you a simple version of the problem and solve a very simple version of the problem in this video to help you get an idea of how to approach it. But first, let's start with simplifying expressions with subtraction of like terms. You guys know that subtraction is the same as adding the opposite. So if I give you the problem 5 minus 3, and you know the answer is 2, that can also be written as 5 plus negative 3. Same answer. So subtraction is just the same thing as adding the opposite. Okay, so what approach that you can use for adding and subtracting terms, like terms, is that you can change the subtracting to adding the opposite, and then you're just adding the terms together. Let me show you. So this is 2b. Instead of this being subtract 7b, you can add negative 7b. Plus a, plus 6b. Instead of subtracting 4a, you can add negative 4a, plus 5. Now let's use the underlining trick. 2b, negative 7b, and 6b are like terms. They all have the variable b. A and negative 4a are like terms. They both have the variable a. And then the constant term 5 doesn't have a variable. That's why it's called a constant term. And it doesn't have anything that goes with it. There aren't any other constant terms. So now I'm going to gather them together. Now we can actually do our addition. So for the terms that have the variable b, we have 2 plus negative 7 plus 6. So 2 plus negative 7 is negative 5, plus 6 is going to be 1. I'm going to write the 1 here. We'll come back to that in a second. A plus negative 4a. So that's 1 times a plus negative 4 times a. So 1 plus negative 4 is negative 3. And then we have the 5 on the end. So let's sort this out the way that an expression would normally be written. Usually the variables are given in alphabetic order and the constant term is at the end. So this would normally be written as negative 3a plus, and we don't usually write the 1. If it's 1b, we just usually write b plus 5. Let's do one more of these. Okay, so 11x minus y plus 2x plus 8y minus 3x plus 5 minus 3. Okay, let's convert it all to addition first. 11x plus negative y plus 2x plus 8y plus negative 3x plus 5 plus negative 3. X terms get 1 underline. Y terms get 2 underlines. Constant terms get 3 underlines. So I have 11x plus 2x. So 11x plus 2x is 13x. Plus negative 3x gives me 10x. Plus negative 1. So negative y, that's negative 1 times y. So that's negative 1 plus 8 is 7. And then I have my constant terms. 5 plus negative 3 is 2. Now, you guys will notice that on the second problem, I didn't write out the line where I gathered them all together. I just kind of did that in my head as I went across. And I'm fine with you guys doing that. I think it is very helpful to do the underlining though, so that you can see what you're adding together. So I would definitely advise you to do the underlining. I'm going to assign you 6 of these problems in formative today. So please type in the answers to 6 of these problems in formative at the end of your math session today. The next thing I'm going to show you right now is an example for the problem of the week. Remember, your problem of the week is going to be typed up in a Google document, and it is going to be submitted by the end of the day tomorrow. So here's my simplified version of the problem of the week. And I did this one about legs and eyes on animals. The one I'm assigning to you is about bicycles. You'll see more in a moment. So here's my simplified version. I drove past a farm with sheep and chickens. I saw 14 eyes and 20 legs. How many of each animal were there? And just assume that all animals are healthy. They don't have any missing eyes or legs. So the sheep and the chickens, both types of animal have 2 eyes. So if there's 14 eyes, there's 2 eyes per animal, which means I have a total of 7 animals. So I know altogether there are 7 animals. The problem really comes with the legs, because the sheep has 4 legs and the chicken has 2 legs. So what we can do is, we know that each animal has at least 2 legs. So I'm going to use up some of the 20 legs I have across the 7 animals by giving each animal 2 legs. So when I give each animal 2 legs, that uses up 14 of my 20 legs, which means that I have 6 legs left over, and I can give an extra 2 legs to each of 3 animals. So let's count the legs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Great, I've used all the legs. So this means that there are 3 sheep and there are 4 chickens. And at the end, I always suggest that you check your work. So 4 times 2 for the legs is 8, and 3 times 4 for the sheep for the legs is 12. Add them together, you get 20 legs. And there's a total of 7 animals times 2, so there's a total of 14 eyes. So our check works out fine. So you can use a similar approach to this for the problem of the week about the bicycles and tricycles that I am going to assign to you. Please email me any questions you have, or type in the comments on your Google Classroom page, and I will answer from there. Thank you so much. Have a wonderful Tuesday. How about even a terrific Tuesday?